Okay, we're continuing this example where we did an LP problem for making bowls and mugs, and we found that the optimal solution was to make 24 bowls and 8 mugs, and the total profit was $13.60. And this is the LP formulation: maximize 40B plus 50M. Subject to, and we have two constraints: B plus 2M is less than 40, the labor constraint; 4B plus 3M is less than or equal to 120 clay, and the non-negativity constraint. And this is the feasible region. Now we need to check some things and do some sensitivity analysis. So this is part 2, continuation of the problem. We need to check if the constraint was binding. Some terminology here. Was the constraint binding? Which constraint is binding? That means plugging the optimal solution in the constraint and seeing if there is a difference between the left-hand side and the right-hand side. So we take the B plus 2M and less than or equal to 40, and so we take 24 plus 2 times 8, so 24 plus 16, and that is exactly equal to 40. So 40 is equal to 40, so labor is binding. So the labor constraint is binding, which means used up. We used it all. Let's check the clay, 4B plus 3M, and see if it is equal to 120. So 4 times B, which is 24, plus 3 times 8. And let's see what that is. And that's exactly 120. So we are binding also on clay. That's what binding means that the left-hand side of the constraint is equal to the right-hand side, and means that you use it all up. If not binding, then depending on the sign of the constraint, there will be slack or surplus, and it will be difference between the left-hand side and the right-hand side of the constraint, which means we could use more of it if another constraint would have more available. Now, what would it mean to have a redundant constraint? What does redundant constraint means? Useless constraint. So if I came and added a constraint like M has to be, add a constraint that M has to be less than or equal to 40, that I have to make mugs, number of mugs made must be less than 40, because the market will not tolerate selling more than 40 mugs. Well, that is an example of a redundant constraint. Why? Because if we come and look at the graph, if we were to graph this, what is M is less than or equal to 40. If I turn this into a straight line, that's M equals 40. So M equals 40 would be a straight line parallel to the y-axis. This is M equals 40. And M is less than 40 is everything to the left of that. Everything to the left of that will intersect with the feasible region and will not change my feasible region. So this constraint does not change my feasible region. and that's why it's redundant. That's an example of a redundant constraint. Now, what is sensitivity analysis? Like I said in the earlier example, you may do it in Excel because it's much easier to do in Excel, but it's harder to do it manually by hand. You just need to understand what it is. Sensitivity analysis means changing any of the parameters, any of the LP parameters, and observing the effects it has on the solution. The solution being the objective function value and the decision variables. So what are the parameters? The parameters can be the objective function coefficient, can be the coefficient of the constraints, how much clay, how much labor each unit uses, can be how much availability of labor and clay we have. All these are parameters of the problem. So the parameters could be one way you change a problem. That would be part of it. Add or delete a constraint can be considered also sensitivity analysis. In some books, so you're adding constraint, market constraint, or anything like that. That could be considered sensitivity analysis, but traditionally the books have considered the parameters as sensitivity analysis. Anyway, you do any of these things and you have to changing the parameters or add, delete, change constraints, any of that, then you have to redraw feasible region if you're doing it graphically by hand, and then you have to recalculate corner points, and recalculate the optimal solution. Unfortunately, this is the only way to do it manually. So there is no easier way to do it manually. And you can only do manually if you have two decision variables. So the best way to do these problems is using Excel, and the easiest way to do it in Excel is using the add-in solver, which is available. You just have to add it in and know how to formulate it. And that's a big advantage of online classes, is you can formulate that and run it so quickly and get the answer without spending 15-20 minutes solving the problem graphically.